Hi, my name is Steven. I thought I'd try something new and just post a YouTube video. So basically, I come across a lot of gadgets. I get a hold of some gadgets. Let's just leave it at that. Today, I've got a light detector. It's pretty cool. Shall we mess around with it? The first thing I want to do is describe it a little bit. So basically, you have the detector part here, just a white orb, I don't know, 1.5" diameter. And you got this detector part here. It's very simple to operate. Just have power off switch, power on, 200-foot candle mode, 2,000-foot candle mode, and 10,000 times 10-foot candle mode. So I guess if you got a huge fucking searchlight, you can read that with the mode here, because here this old screen wouldn't be able to handle that. So, but anyway, and then that's literally like there's two switches here, and one of them takes you from a data collection mode, which we're in now, to a hold mode, in case you want to, I guess, write it down or something. Looks like the ambient light in this room, according to this AW Sperry SLM 110 light detector, is around 11 11-foot candles. Not sure if I'm reading that right, because we're in the 200 mode. So do you multiply it by 200? I don't fucking know. Maybe you can comment. Anyway, I'm just gonna say 11-foot candles. Cool. Seems to work. So, I mentioned before I have no clue if this light detector works. So I'm going to get to that right now. So I got myself a flashlight here. A little mag light that I had in my car. And then I got my big mag light that I keep by the back door to clobber anybody that breaks in my house. Okay, but they actually have quite a bit different brightnesses, which any idiot can see. Okay, but we want to make sure. Let's just see if my light detector will be able to tell the difference. If it can't, then this thing's a piece of garbage. Okay, first test. Turn it on. You can see the detector here. Let's go. Reading ambient light, as I said a minute ago. Oh, I'm blocking the detector. Ambient light's about 11, okay? At least it's consistent. Alright, so let's do the small mag light. Ooh, you know what? We better standardize the distance, eh? At 1 foot, shining directly on the detector. Let's see if I can do this. Oh, interesting. Oh, shoot. You can see. Very interesting, okay? So that's pretty good. Directly at the detector. About 100, looks like. Yeah, it's consistently about 110, maybe. Alright, now the big mother... Okay, let's do the... Set it up, 1 foot. Oh, look at that. It's not even reading anything. Alright, looks like we gotta make use of those modes that we talked about before. Alright, so now I'm switched into a factor of 10 higher. And as you can see, we need it. Getting 720, 740, looks like. I'm reading it backwards. So sorry if I'm... Well, I'm really shaky, kind of, so... Looks like if I get as much of the beam as possible, the highest it gets is about 750. 770? Something like that, okay? 770 versus about 100. I mean, I could buy that. I could buy that this thing is 7 times as bright as this thing. I really can, I can believe that. At least in this 1-inch diameter area. I mean, because if you think about it, putting off a lot of light that's wasted, not being picked up by the detector. Anyway, okay, good. Looks like it might work. That's sweet. Alright, so the final thing I'm going to do with my light detector is see if it can detect light outside the visible spectrum. Because as we all know, light, visible light, is only a really tiny part of the electromagnetic spectrum. You got microwaves, you got gamma rays, you got sound waves, I think, even. Is that true? I think sound waves are pressure waves. Anyway, you get my point. Radio waves. That's what I was trying to think of. So, okay, so can I shoot a radio wave at this thing and it'll detect it? I'm guessing not. Okay, I don't have a radio sitting around, but I do have a remote control. Now, what are you thinking? You're thinking, what the hell? Remote control, what does that emit? Well, let me tell you. In fact, I can show you what it emits. It emits UV light. And it just so happens that my phone does not have a UV filter in the camera that faces toward me. So I can show you right now what I'm talking about by saying my remote control shoots UV light. Ta-da! I can see, you can see that purple flash. In real life, as I shoot this video right now, I'm looking at it with my naked eye. There ain't nothing coming out of here. But when I look at the camera, boom, boom. Okay, so does the light detector detect UV light? I don't know if this is gonna work, y'all. I would say no. But let's do it. Science. So we got our normal control, ambient about 10, 11, something like that. It's getting a little darker, I guess, outside, so that could explain why it's only 10.1 now. Alright, so I guess what we're looking for is if it spikes. Well, alright, it's hard to do with 2 hands. Alright, let's do the same thing we did before. I'm gonna have to just try to hit it this time. But that's okay because all I want to see is any kind of spike. Let me set this up here. Maybe you can see. Alright, so I tried to set it up so you could see. Now, I understand that it's 9.3 now, but that's because I had to rearrange some shit. We got a skylight in this room, so now there's probably an extra shadow or something, so whatever. Does it spike when I shoot it with UV? Okay, we got 1 foot away. Let's just start here. So what is it, 5? I'm just going to hold down this button and see. 5. Can't tell if I'm even hitting it. Okay, that's tricky. Alright, where am I at? 9. Is it 9.2? I'm going to have to shoot it at an angle so I don't block the light. I'm looking for a spike here. 9.6. It's not really doing anything, folks. But, haha. Let's hit it. Let's really hit it. This one should be shooting too. Yeah, now I got double. 0.5. Thing seems to be happening. Now I can do these two. Does this one work? Yes, it does. Okay, now I got 3. See if this works. 1, 2, 3. Okay. Engage. 9.5. 9.6. Maybe. 9.7. Ah, 9.6. I'm gonna say that okay, because I'm turning it off now. Sorry, I guess you can't tell when I'm turning them on or off. Maybe you can. I don't know. Okay, so it's 9 point. Let's try this once more. 9.5, right? Okay, I'm turning on right now. Okay, 9.6. I don't know. And I turned it off right there. 9.4. Okay, 9.3. We're stabilized at 9.3. Let's turn them on now. 9.6. Oh, shit. I think this is working. I'm actually pretty happy with that result. Scientists are going to be like, you got to reproduce it 3 times. All right, fine. Let's do it 3 times. Let's do that one more time. All right. So, okay. Fuck. That's good. That's okay. Oops. That's okay. Variability. We're introducing variability, which can strengthen our conclusions. Okay. Boom. 1, 2, 3. All right, all 3 on. Wait for it to stabilize. 9.3. Let's turn them on in 3, 2, 1. Boom, on. Oh, 9.6, almost perfectly. And I'm having trouble aiming them, but okay, turn them off. Let's turn them on again. 9.3 to 9.5. Okay, I'm convinced. Now, I think that UV thing was really cool because the only way that that result is falsified, to me, is if the experiment, well, so now I think that result with the UV light was pretty freaking interesting. I can see if the reading went down and I was detecting if there was a loss in light, I can see that being a poor conclusion because, well, maybe the act of pressing the button was making the remote move, and then a shadow appeared across the detector, lessening the value here. But by pressing these buttons, I'm actually adding light to the system here. I don't really see how that could be unless by pressing the button, I'm moving the remote. So that's cool. I mean, I guess you could take it outside and see how fast you'll get a sunburn. Alright, YouTube, that was Light Detector. Please like or subscribe. You know, this is a new YouTube channel. If I can get 10 subscribers, I'll make another video with a new gadget. Cheers.